So this is the problem that I think would be good to demonstrate understanding of Newton's laws of motion. Two blocks with masses m1 and m2 are connected by a massless string that passes over a massless pulley as shown. M1 has a mass of 2.25 kilograms and is on an incline of theta 1 equals 42.5 degrees with coefficient of kinetic friction mu1 equals 0.205. M2 has a mass of 5.85 kilograms and is on an incline of theta 2 equals 33.5 degrees with the coefficient of kinetic friction mu2 equals 0.105. The two-block system is in motion with the block mass m2 sliding down the ramp. So find the magnitude a2 of the acceleration on the incline. So I chose this problem because it includes tension, friction, and two masses moving along an inclined plane. This question was hard for me when I was doing the homework, so I thought this would be a good question to go over. So first, I would make note of some important things like the given values and the direction of the acceleration. So mass 1 is accelerating upwards and mass 2 is accelerating downwards. Also that A1 and A2 have the same magnitude and T1 and T2 have the same magnitude. So next I would make the free body diagrams for the two masses. So here for mass 1 we have the tension, the normal force, and then the weight, and then friction and acceleration going in this direction. And for mass 2 we have the normal force, friction, tension, and the weight and acceleration going in this direction. And then the weight isn't along any of the two planes for these masses, so it's broken down into its x and y components. So after that, I would write out the Newton's second law equations for the x and y components of each mass. So for x, we have f of x is tension minus the mass 1 times g sine theta 1 minus mu k1 times n1 is equal to mass 1a, and then the same thing for mass 2. And then we have the y equations for the two masses. So the next step would be to solve for n for both of the y equations. So since neither of the masses are accelerating upwards, both the equations are equal to 0. So n1 is equal to mass 1 times gravity times cosine of theta 1, and n2 is equal to mass 2 times gravity times cosine of theta 2. So we can plug these in to the x equations, and we get these two equations here. So we're solving for acceleration, but we have two unknown variables in these equations. We have tension and we have acceleration. So what we can actually do is we can add these two equations together, and the tension will cancel out, and we get this equation is equal to mass 1 times acceleration plus mass 2 times acceleration. And we can actually pull acceleration out and get acceleration times mass 1 plus mass 2. And this would set us up for the next step. So the next step would be to rearrange the equation to get acceleration by itself. So you would get this whole equation right here. And then we have values for all of these unknowns, so you would just plug them in and do the calculations, and then you would get acceleration.